What would you do with a 1200 horsepower Gen 3 Hemi? Hi, I'm Greg Acosta, the editor of EngineLabs, and we're here once again at PRI 2023 building our giveaway engine. This year, it's a Gen 3 Hemi. We're here once again with Vinny Monaghetti from LME, our friend, our builder. Vinny, tell me a little bit about the engine.
So this year, Gen 3 Hemi, 427 cubic inches, and we're putting a 3.8 liter Whipple on it.
And we're gonna make a lot of power, aren't we?
A lot of power.
All right, so if you're not familiar, every year we put together a giveaway, an engine to give away. Last year was a Godzilla, the year before that was an LS. Never under 1,000 horsepower. This year we're going for 1,200. Tell me a little bit about this compared to the other two we've built.
Well, Godzilla still haven't really evolved yet into, like, it's obviously a great platform for like hot rodders, but Hemis have been around as far as production in cars and stuff for a long time. And the platform is great. I mean, the guys are making a lot of power. They're real strong platforms. And this is basically like a Hellcat base. So it'd be what you find in a Hellcat.
So we're gonna be doing slideshows and donuts, and well, the winner can do whatever they want. You can put this in whatever you want. I mean, you want to go do slideshows, do slideshows. You got it. Well, 1,200 horsepower and a heavy boat. I mean, they could still. That's an easy 8-second pass, isn't it? You can run 8s with this thing. Put it in a real race car, you go 7s. All right, Vinny. So what's the plan for today?
So today we're gonna go through the short block and check all the critical clearances, gap rings, and get the base done.
And we're doing that legit on the show floor. Like this isn't make believe. Like I know we've got the ring grinder back here. I try to steal it every year, and every year you take it back from me. But it's Thursday, it's day one. Let's go.
Big ass slide hammer.
So while Vinny gets the block prep, let's talk about some of the parts that are going to make the short block awesome. Right now we've got the Cali's crank. It is a 4330 steel, forged steel crank. Vinny, this is it's a 4095. So this is a 4050 stroke. And we'll be using 4095 pistons to make the 427 cubic inches. So as you can see, LME has balanced this with our rods and pistons. And it looks like it took a little bit of weight. But this is a Cali's Comp Star line. So it's forged steel, but still not, super expensive. But more than enough for us to handle 1,200 horsepower.
All right, so I'm gonna basically mic the crank to see what size it is. We're gonna pull these bearings out of the box, install them in the main caps, and then we're gonna start checking actual clearances. Basically, I'm gonna measure the main journals. So you basically measure the main journal, you measure the installed bearings in the main bore, and then the difference of that measurement is your clearance. We're going to check the size, but we're also going to check out around and taper at the same time, and make sure that all the tolerances are within spec.
Vinny, what's your favorite part about building an engine? What part do you enjoy the most?
Seeing the results after it's done.
All right, so for this engine, we're going to be using King's PMAX coat bearings, which are their PMAX black bearings, but with a polymer coating. The coating will provide extra protection in the case of temporary oil starvation, and it provides extra embeddability in case anything were to come through the engine, it will, basically the bearing will hold it and absorb it as opposed to scratching and destroying everything downstream. These will allow not only efficient high RPM operation, they will withstand all the loads we're going to get on this with such high cylinder pressures with the blower.
So do you torque it till it feels loose and back off the quarter turn?
Explain to our audience why you're torquing an empty engine, basically.
So I'm basically torquing what actual bearings we're planning on using in the main caps. What that allows you to do is see how the bearings crush, see the crush on the bearings, and get your actual measurement instead of, some people mic the crank, the main bore, and the thickness of the bearing. But what you don't take into account is the fact that the bearing is crushing. So it's actually moving around more than you think.
So instead of being on paper, we're actually measuring what's happening in the bore under torque.
We want to know what's actually in the engine and what it's doing, yeah. Now that the crank's in it, I'm going to check thrust and make sure that's the spec, and then we'll go ahead and start checking rod bearing clearance.
So here we've got most of our rotating assembly components. We've got these nice Cali's Ultra Enforcer rods. They're 4330V forged steel I-beam design, so these things are going to hold some serious power. They've got really good rod bolts in them. Then we've got the Diamond HEMI 2K pistons. These are basically all the whiz-bang features you can get in a custom piston, but in an off-the-shelf part. And then they come with these beefy wrist pins from Trend. And one thing you'll notice is with the compression height, we're intersecting the wrist pin with the oil control ring. So we will be using support rails, which are not here. Okay, that's cool.
About to hang rods on the pistons. We're going to gap some piston rings, and then we're going to throw it in the engine block. Got to get the ring grinder out so we can gap some rings. Gapping these 25, 28, 25 on the first, 28 on the second.
Piston ring compressor got left back in the shop in Texas. So we are going to head out on a mission to find a new ring compressor. It looks like Total Seal is actually disassembling their display for us. In the middle of the trade show, they are disassembling their display for us. So here we are, end of day one. We have a short block, mostly assembled. We still need to stab the cam in, then we can start working on the top end and the valve train. That'll be for tomorrow. Today, we had a good day of work. Vinny busted his butt. I took some pictures. And with that, we're gonna close out day one. We're gonna go have a beer and see you tomorrow. It's day two here at the PRI show. We got our short block built last night. We didn't get the cam in, so we're gonna do that today. This cam came from Cam Motion. They spec'd it out specifically for this build. I've got the cam card right here, so let's go over its specs a little bit. So it's got 116 degrees of lobe separation angle, so there's not too much overlap with the boost. It's got 670 thousandths of lift on the intake side. It's got 653 on the exhaust side with our rocker arm ratios. It's got 242 degrees of intake duration at 50 and 254 degrees of exhaust duration. So we have a lot more exhaust than intake because the blower's making all kinds of spent gases. We gotta get them out. So this cam should make quite a bit of power. Looking at the specs, and yeah, this thing's gonna make some noise. It's gonna boom.
All right, good morning. We're here at PRI. It's day two. Yesterday we got the short block finished up. We're about to install the camshaft so that we can start knocking out the long block. Before we do that, we have to install a phaser lockout in this Mopar phaser so that there's no excessive cam movement with the high spring pressures and horsepower. So this lockout from Cam Motion, you'll see as I pull this apart, it literally just slides in and it'll eliminate any free movement of the phaser. Right now I'm verifying the TDC on my timing wheel so that we can degree this cam and verify the cam is installed correctly.
I'm here with Kale from Melling. Kale, we have this cool new pump. It's a Hellcat pump or it's a Hellcat aftermarket pump? Tell me about it.
So what this pump is, this is the high volume version of our 10452 pump, which is a standard volume pump for the later model Gen 3 HEMI engines. This is the standard volume pump for the Hellcat engines. The Hellcat engine OE pump was 20% higher volume than the later model OE pump.
And I'm assuming that's due to the supercharger and the supercharging system.
Mainly, yes.
And the requirements for all that.
Yep.
Which is why it's perfect for this, because we're going to make 1,200 horsepower like a Hellcat will.
Exactly.
In the same fashion, just turned it a little bit.
Yep. We want a little more volume, get that pressure up in a boosted engine, put a little bit more oil in those clearances. That way we've got a little bit better shock absorption from the added cylinder pressure.
Awesome. So, are there any RPM limitations with the gerotor type pump?
Any wet sump pump, there are limitations to. A lot of those limitations are based on the build as far as windage. Controlling the windage in the engine is really, the big issue with, we've got to keep that oil down in the bottom of the pan and off the crank.
Okay, so we're running windage tray and we're probably only going to spin this to maybe 6,500, probably 6,000, so we should be pretty good.
Should have absolutely no problems with that RPM.
Awesome, so I'm looking forward to running this on the dyno and making some big power.
Okay, good deal.
moving right along on day 2, and we're getting ready to put the oil pan on. And for this build, we're using Mylodon's Gen 3 HEMI oil pan with their windage tray. The cool genesis of this particular part was this went on the 2nd generation drag packs, which really took care of some high RPM oiling issues. And one thing Mylodon's really good at is controlling oil. Between the trapdoor baffles and all the heavy, blocking off here, and their windage tray design that really controls oil slosh, you can be going, 8,000 RPM through the traps and not have to worry about any kind of oil starvation or oil aeration. So when we're making, 1,200 horsepower and probably not as high a RPM as the drag packs are spinning through the traps, we know we're going to be extra. So we're getting ready to put the damper on the HEMI. Our friends at HEI sent us over this super damper. This particular model has the incorporated supercharger drive, the 10-rib supercharger drive, and this model is a 10% overdrive model. That means that it spins the blower 10% faster than the standard damper. Now that's going to mean a lot of boost. We're already going to be making a ton of power. This 1200 is not going to be hard at all. So before we can put the heads on, we've got to get the lifters in. Our lifters are a set of Johnson lifters. They are their short travel race lifters, and they might look familiar to you because they're very similar to an LS lifter, a little bit longer. And like an LS, they have flats on them that slot into a lifter tray to prevent rotation and keep the wheel in line with the cam load. The short travel is about a third of a factory lifter travel, and it's going to more efficiently translate the cam lobe's motion into valve motion. So with that, we need to go get these into the block so that we can get the heads on. So here are the heads that are going on our Gen 3 HEMI. They come from Thytec, and so does Craig.
Yes, how you doing?
So Craig, tell me a little bit about the genesis of the Thytec HEMI head.
Been out roughly about 12 years. It was more of, started off as a replacement head. That's kind of the angle with everything, where stock rocker, stock intakes, headers, everything. So it's a true bolt-on head. Manufactured in the USA, A356, T6 aluminum. This head has the 2165, 1650 valve sizes with a 72cc chamber, which is my standard chamber with a taper quench added to it or softened.
Well, now let's talk real quick about the chambers. That's what makes a HEMI, right?
Yeah.
The hemispherical
Design.
What was so popular about the hemispherical over, say, a kidney shape or the wedge?
These work really great for boost. Older HEMI guys say that this isn't a real HEMI, but it is. Peak flow on these is, depending on bench, 400, 405 CFM.
Oh, wow. And what's the runner volume?
It's approximately 205 cc.
Okay. Wow, that's a lot of flow for not a lot of running.
The port's deceiving, actually, because when you look at it, it comes at an angle, but if you go straight up and down, it's definitely a different shape to it. The exhaust side, this has our 2-inch header port in it. They'll peak 270, 275 without a pipe on a 4060 bore.
So these heads are going to handle everything we throw at it with this bad boy right here.
Oh, yeah.
In order to seal up the heads, once we put them on, we've gone with Cometic's MLX line of MLS gaskets. These are 40150 bore, They're 054 thick, which is going to give us a good solid compression ratio for boost. The MLS design is really going to withstand all the cylinder pressure we can create and stand up to the power. And I know that LME uses these on the day-to-day, and so we decided to use them on this build.
What do these get torqued to?
782 foot-pounds.
700, where's that breaker bar you're talking about?
With the heads come a very, very, very awesome Valvetrain from Jessel. I've got Grant here from Jessel. Can you tell me a little bit about your new HEMI Valvetrain?
Sure, Greg. So this is a direct factory replacement bolt-on system. Utilizes factory shafts. Push rods are in the same location, doesn't require any clearance in the cylinder head, no machine work whatsoever. Features are, they're made out of our proprietary forging that we make our top fuel rockers out of. Bronze bushings, needle roller, adjusterless cup, press in, pressurized oiling through the shaft to the cup, down through the push rod to the lifter, just like a traditional factory style, so you can maintain your hydraulic lifters. And you can run up to about 700 thousandths lift or more in most applications. It's a real nice piece, direct bolt-on, tie in these stank, bridges between these nice retaining collars to keep everything in place, and it's a real nice package overall.
So you've got more stiffness than even a standard shaft rocker system.
Absolutely, even just with these braces, but when you tie everything together, really it kind of creates a complete package with the upgraded hardware. It's kind of hard to top it, really.
And we were talking, this is part of Drag Pack? Or this came from Drag Pack?
It was inspired with the Drag Pack motor when Dodge came out with that. There was a need for it, and we kind of stepped up to the plate and said, all right, let's get into this. And we at the time already had a kit available, but it required a lot of machine work. So it wasn't exactly your weekend driver friendly type of product. And we felt that it was time that we brought something more available for a wider variety of applications to the market.
Well, considering how many of these engines we see on the street, making huge power, it only makes sense to have a nice bolt-on setup that isn't, super custom.
Right, it is. And granted, it's not for everybody, but for those that are in the upper power level range, it's definitely a huge benefit for valvetrain stability, as well as longevity of the motor entirely. When parts aren't happy and flex around a lot, it causes unnecessary wear throughout the entire engine, and this kind of solves a lot of those problems.
Now, this being the bolt-on versus your old custom one, are there any limitations of this one compared to your other one, or is this just a bolt-on solution for everything?
This is a bolt-on solution for a majority of applications, but when you really start getting serious and into higher lift, say you run a longer valve, things of that nature, we're limited with the factory mounting locations and the factory shaft locations, so there's only so much we can really do.
When you start to mess with that, you're getting out of bolt-on territory anyway.
Yeah, we're getting away from this and getting a little more serious, which we do have offerings for, but this is just a real nice factory replacement type piece for
Anybody
hard to beat. Yeah.
Well, I appreciate you guys supporting us, because thanks to you, we can make power reliably and not have to worry about anything, because I know this blower will make twice the power we want to make.
Oh, sure.
So it's good to know we have supporting parts. So thank you.
Yeah, absolutely.
And thank you for supporting us.
Thank you. Thank you, Greg. Appreciate your time.
Our engine build process, we always talk about LME being a great build partner, and they are, but there's so much more than that. As you can see here, there's a bunch of billet valve covers. They're also a parts manufacturer. They've released a new billet block at this show. We've got new billet intakes. Colin, tell me a little bit about the manufacturing side, because yeah, you guys build engines, and I don't want to take away from that, but you also make parts.
Yeah, so LME has started out originally as just doing cylinder heads, then we got into engine building, and within the last 5 years we've really gotten into doing a lot of the manufacturing of billet parts. So when the Gen 5 LT came out, that's kind of when we started doing most of all of our billet parts. We came up with a variable valve timing delete front cover. That was our most popular billet part starting off probably in the 2018, 2019 era. And then going from there, we just started building intakes for almost everything. Now we have intakes for LS, LT, Godzilla, and obviously we're doing Gen 3 HEMI stuff now. So we're just trying to make parts for everything, and the more new engines that come out, we're just going to keep building more products for them.
So now we're here to discuss starting and charging for our Gen 3 HEMI, and we're here with Todd from PowerMaster. Todd, the first thing I want to talk about is one of one. This is literally the first prototype of the new starter. Can you tell me a little bit about it and what we're seeing new with the prototype?
Well, with more and more HEMI swaps becoming more prevalent stuff, we're getting more calls for late model HEMI starters, of course. So the team has been able to put together this compact, nice lightweight starter. It's got plenty of high torque to it. It's got a billet mounting block, and you can see that, since we don't know what this is going in, it depends on the transmission, but even more so with different headers, frames, body parts and stuff, we can clock it so it'll make lots of good clearance when you install it.
So it's not just for different applications, it's for different applications.
Yes, who knows what this engine's going to end up being in, and then since they're putting late model HEMIs in just about anything these days, we got to be prepared, and with the clocking, it'll fit pretty much anything.
Very cool. So so we're going to start, and then we're going to charge it.
Yeah, we got the cranking and the charging.
Yeah, so let's talk about the alternator here. Is this a power? Is this a HEMI specific unit, or is this just a HEMI specific bracket?
No, this is a HEMI specific. It's what we call our HPR starters, which make great current at lower RPM as well as at higher RPM. This one's going to make up to 195 amps at idle, and then 250 at top RPM. And the great thing is it's a direct bolt-in onto the factory HEMI bracket, so it'll go into Jeeps and Hellcats and everything like that. And there's two different sizes. There's a large frame and a small frame, depending on your application, but it's a direct bolt-in.
And the frame sizes, does that affect charging ability?
Yeah, this is the large frame, so it's that 195, 250. On the small frames, they're 150 to 190, just because we can't pack as much material into them.
Well, back in the day, 150 was a big peak for us, and now we're talking about doing that at idle.
At idle speeds. These modern engines idle so low that we had to go back to the drawing boards and develop a complete internal system that could support fuel pumps and fans and ECUs and air conditionings and stereos, all when you're sitting at an idle at the fairgrounds or the stoplight or in the staging lanes.
So no more flickering needle, no more.
No more. It's going to be a rock solid needle just sitting there.
Very cool. And we're probably not going to spin it super high, so we don't have to worry about overspinning it. But we're going to be putting a lot of power through it, and it's going to be making a lot of power. So I guess power is the key word here.
Power is the key word to PowerMaster. That's it. We're going to make it all for you, so you guys can make more power. But on that subject, the other cool thing is this makes all that energy, makes all that current with a stock diameter pulley. So we're not overdriving the alternator. You can use your factory belt, so it's one more thing when you upgrade your late model HEMI, you don't have to change the factory belt.
Very cool. Because I mean, nothing's worse than when you're having to completely reroute everything else for a new accessory.
Yeah, and make 3 trips to the part store to get the right belt. Nobody likes to do that, so it's a direct bolt-in application.
All right, well, thank you, Todd. I appreciate it. I appreciate you guys supporting our project, and I cannot wait to see these things on the dyno.
No, we're really excited to see this on the dyno and on the finished project, and to whoever wins the engine. what they're going to install it in. We're looking forward to it.
Well, that's right, because you have to talk to them and figure out what we're going to get them.
We're going to see what we can do on the starter.
And this right here is the star of the show. This is the power maker, the noise maker, the boost maker. It's a 3.8 liter Whipple supercharger, but it's a Gen 6. We have Dustin Whipple to explain to me what's new in the Gen 6.
Yeah, well, the Gen 6 is basically an enhancement from what the Gen 5 was. We went to a newer rotor profile. It's a little bit longer rotor, a little smaller diameter, and a new profile. That's the main part of it. And then after that, we came up with a new port shape to help increase airflow at a lot longer RPM ran. What that helps is you don't have to race port one up to a much higher RPM. So right from there, and you lose no torque, but you gain a lot of power all the way up to about 21,000 RPM.
Okay, so now I remember when we did a test, we did a Gen 3 to Gen 5, and we picked up significant power.
Yes.
Are we looking at the same kind of gains from Gen 5 to Gen 6?
Not quite as much as that, because that was groundbreaking difference, right? But this between Gen 5 and Gen 6 at the peak levels will be about 350 to 400 horsepower variance.
Okay.
So it is still very significant, but it's obviously based off of RPM and boost and everything else. In a stock form, it would be a lot less. Obviously, it is a significant gain in power and efficiency, so it is better all around. But the biggest power is the more modifications, the more airflow this thing needs to pump, the better this is going to be.
Yeah. Now this is a 3.8. Will a 3.0 liter be coming in the Gen 6?
Yeah, it's coming. It's coming very soon. Very similar design. It uses the exact same lid, and very similar to exactly what this is right here. So it's got all the new port shapes, new rotor profile as well. Yeah. So that's for the HEMI and Hellcat are both coming out.
Okay. So now, what are we looking at airflow wise on this? What is this capable of? Because this thing's massive. It's a big boost maker.
The main goal in a full race trim, with very good heads, some very good head gaskets. This can make about 2,800 horsepower.
So the 1,200 that we're going to be making with it, it's still going to be asleep.
Yeah. This will be 1,200, not a problem.
So. Are we doing anything with the pulley size for this? Like, are we just, since this is so capable, are we just going to run a really big pulley up top so there's no belt slip issues?
Exactly. Exactly. The Hellcat belt system already has a pretty big balancer for the smaller blower, stock. So even with that biggest pulley we can fit on there, it's still got a lot of power.
How much boost do you think we're going to be making on that combo?
I would say somewhere in the low 20 PSI range.
Okay, so we're going to be making some big boosts.
Yeah, it's gonna make some power. Yeah.
All right, very cool. Well, we thank you very, very much for being a part of this project, and I am so excited to hear this thing spool up because they make such a beautiful music.
Oh, absolutely.
All right, our time at PRI with this engine build is coming to a close, but it's not over for you. You still have until April 2nd to go to EngineLabsGiveaway.com and get entered to win our Gen 3 HEMI. This thing has gone together amazingly well. It's gonna make a ton of power. Vinny has busted his butt. Vinny, you've been here for 3 of them now. Give me your thoughts on the HEMI, number 3 of the big 3.
Another platform to test out and see what we can do with it. Planning on making some bigger power with this one, I think.
Today is a special day. We're here at LME in the Dino Room, and we are about to dyno test our Gen 3 HEMI. It's a Gen 3 HEMI, 427 cubic inches, not 426. And it's got a Gen 6 3.8 liter Whipple supercharger on it. And this thing is gonna make at least 1,200 horsepower. Now I say at least, because it is packed with some of the highest end parts you can get. And we're gonna make a ton of boost. We've run the numbers, we've made the claim, now we're gonna prove it, so stay tuned. So we've just wheeled the engine from the build room out here to the dyno. We're gonna transfer the engine from the engine stand that it was built on over here to the dyno cart. And what's cool about this is it lets you easily swap engines on the dyno. You basically, this is actually your bell housing, and then you've got your support here, and it just clicks into the dyno. You hook up your little spindle, and you're good to go. To make horsepower, you need air, you need spark, and you need fuel. We've gone with Fuel Injector Clinic's 1,440 cc a minute injectors to provide the fuel where we need it, when we need it, and in the amount we need it. 1,440 cc's should be plenty for what we're trying to make. We're trying to make 1,200 horsepower. On E85, this should have enough headroom for about 1,400 horsepower. I don't think we'll be running E85, but it's nice to know that if we do, we have plenty of room in this injector. Another little safety benefit is these are flowed at 43.5 PSI and we'll be operating at 55 PSI. So that basically makes the injector a little bit bigger. Now that we've talked about how the fuel is going to be delivered, let's go talk about the fuel that is going to be delivered with Ian from Boain. There's absolutely no way we're going to try to run just straight 93 pump gas. But 93 plus Boain is a different story. We have Ian here from Boain, and we're going to talk a little bit about how Boain turns 93 into legitimate race fuel. Ian, we've done this before. Like we've used it. I know it. Like this isn't a test.
Yeah.
But explain how we're turning, pump fuel into race fuel with a can.
Yeah. No, I mean it's there's a lot of different components that go into it. Obviously, we developed some technology back in the day for kind of our own personal use. We needed a high octane race fuel equivalent solution for the racing that we were doing because we couldn't get a hold of race fuel or it was too expensive. So we developed a proprietary carrier that keeps a lot of the active ingredients that you would find in race fuel in a concentrated form and allows them to stay in solution. So, for somebody like this who's going to be putting this motor in kind of God knows what, obviously something that's going to go pretty fast, but what we're trying to do is offer that guy a solution to not be chained to a drum in his garage because, like you said, you're not putting 93 in this. I mean, you could once.
Maybe twice if you're really lucky.
Yeah, if you're really lucky. But ultimately what we want somebody to be able to do is if they're going to build a motor like this and customize it and put the power out, we want them to be able to go and enjoy it and to be able to do that without worrying about where their next 5-gallon pail is going to come from as far as race fuel is concerned. And that's where Boain comes in, because we're going to be able to help them customize their fuel and their octane rating to exactly what their engine's going to need.
All the fuel and all the air in the world isn't going to mean much if we can't ignite it. So for the ignition on this project, we are running Brisk's Silver Racing plugs, actually 2 sets of Brisk Silver Racing plugs because the Gen 3 HEMI runs dual plugs per cylinder. Now, to ignite that, we've got these Sultans of Spark coils. Now you may know them from the LS or their Coyote or any line of their coil on plug plugs. But what is unique about these coils is you have one coil pack for 2 plugs. So that is going to ensure we have a nice hot spark. The silver is a highly conductive material, so that's going to ensure we have a nice hot spark. And between the two, we're going to keep the fires lit and make some power.
Now we got to figure out how much Boain we need to add, because we're estimating about 2.5 gallons in the tank and about 1 gallon in the system. So now we got to now we just got to do a little bit of math. So essentially we're starting with, here are the typical fuels you're going to find at your average gas station. We're going to start, we know that we got 93,
let's shoot for 103. And then he said that we're treating 3.5 gallons. So to transform 3.5 gallons of 93 to 103, we're going to use 9.52 ounces of Boain Professional. So yeah, let's call it 10 ounces for easy math. If you can measure out a half an ounce, by all means do that, but we'll take a little bit of the guesswork out and just call it 10 ounces, but we'll be good to go.
Everything's ready to go. Now it's just a matter of tidying everything up so that none of the new wiring is in the path of any belts or anything. And we're about to make some noise. I know I've said that quite a few times, but we're ready to make some noise. We're gonna be making some power here. Up first, we're going to be testing with the stock Hellcat manifolds with Boain and 93 octane pump gas. And we're gonna see what kind of power we can get through the stock manifolds as a baseline before we put on those beautiful Cooks headers.
So generally, break-in procedure would be starting it, getting it to run, kind of dialing in our part throttle, no load fueling and whatnot, and then the computer will go through an automatic break-in cycle between 4,500 and 5,500 RPM for a course of 5 to 10 seconds. So it's just going to sweep it up and sweep it down at part throttle, whatever throttle and load you want to give it. So generally we give it a little bit load at first, and then we'll kind of do that again with short dyno sweeps under progressively more throttle position, so under progressively more cylinder pressure.
Pulled the plug, a little bit sooty, but that's because we never went full throttle. Also, color was a little different, but that's because of the additive. And there's no conclusive timing mark because we haven't gone full throttle. So we are going to wipe off the plugs. Everything looks okay, and we're gonna use all the other data logging to kind of get close and a little more in the ballpark and give it a full pull.
Why? Why? Just do it.
because we're going to be moving so much air with that giant supercharger, we needed to go with a big primary header. Cooks makes a big primary header. We went with a 2-inch primary. Now normally when you think of a big primary, you're talking 1 3/4 inch, 1 7/8 inch. Now we're talking 2 inches. That will move a big volume of air. The cool thing about these headers, they have a 3-inch collector. Now that means that any exhaust you have that will header back will connect to this without any special, flanges or reducers or anything. It'll bolt right up. So our winner will not only get a set of monstrous tubing headers, it'll bolt right up. So we're not giving anybody a headache. So now that we have the Cook's headers installed, this is a good time to compare and contrast our Cook's 2-inch primary stainless headers with a factory Hellcat manifold. This is what we made our Breakin runs on. Obviously this was built to perform because it's on all the 700 power Hellcat stuff, but that's its limit. These are built to make tons of power. If you'll notice on this, we've got kind of a cast-ish manifold design, short runner, completely unequal length, and it's designed to fit the application, keep heat in it, to light up the catalyst, and just be easy to produce. These are designed to make power. You've got much longer runner lengths, much more runner volume. When we're pushing, a metric ton of air, we need not just escape, we need velocity, we need, scavenging, and that's what the Cooks provide. As you can see, just versus the weird stamp thing, we've got like a really nice fabricated collector. We've got, these tubes with these nice, even, smooth mandrel bends. The Cooks are gonna make a lot of power. Now that's not to take anything away from these. They did a great job and they do a good job for what they're intended for. These do it better. And that's what we want, because this engine isn't about doing what it does from the factory. We're doing everything better here. Last night we left off at 1,199.0 horsepower. So just 1 horsepower shy, but that was with the stock manifolds. To this morning, we put the Cook's headers on. The tune-up has not changed. We still have a little bit of timing left to go, but right now we're not changing anything because we want a direct A/B comparison. So we've got fuel in with Boain, we've got Boain in us. We're ready to go. Let's go make some power. Made our back-to-back pulls, and as you can see with this dyno, we made 49 horsepower just by switching the manifolds. No tune-up changes, nothing, just taking off the cast manifolds and bolting on the tubular Cooks. And what's really impressive is, yeah, we have peaks of 49 horsepower, but if you look at the curve, you can see where they're working. Down here at 4,500, pretty similar, not a whole lot of work being or difference, because we have not as much exhaust flow. But then when we get really going here, you can see that where they diverge and the Cooks just keep on going, whereas the stock manifolds were laying over. They were done. They were at their limit. But we have more left in the Cooks. So with more left in the Cooks, we got to go mess with the tune-up. That means we're going to make more pulls. So I'm gonna come back after we make some changes and make some more power. Let's go. Our time at LME has come to an end. What have we learned? Well, we learned I would never try this on straight pump gas. I learned that Boain really does work, although I kind of already knew that. We learned that Cook's 2-inch primary tubular headers were worth 68 horsepower over the stock manifolds, as you can see here. We ended last night with the stock manifolds at 1,199 horsepower, and we ended today at 1,267.3 horsepower. So we're definitely giving the winner a 1,200 horsepower engine. So if you're not entered, make sure you go get entered at EngineLabsGiveaway.com. And if you are entered, cross your fingers, go rub your troll doll, knock on some wood, whatever you need to do to increase your chances of winning, because I guarantee you want this engine. Also, I want to know, what should we do next? While this may be, coming to a close, I want to know, what do we do next year? What do you want to see? What do you want? What do you want to win next year? Let me know in the comments below. But until then, stay tuned. We've got a lot of cool other content coming to you. And until then, I'm Greg, and I'll see you later.